Can you guys see my screen?
Yes.
Okay. All right. So today I decided to do something a little bit different than what I was originally planning. And part of that was inspired partially from last week's talk that Jeff gave regarding different patterns, one of them being the visitor pattern. And that actually reminded me of a talk I was having earlier that week with someone regarding another way of dealing with basically presenting or dealing with having different types that are all kind of part of another type. So that way being actually using algebraic data types. So before we get into that, what are algebraic data types? They're just a way of structuring data where a type is composed of other types. They're especially popular in functional languages. They're often a composition of simpler types, and we can even structure popular data structures that we know, like lists, binary trees, queues, using algebraic data types. There's two different product types. Product types are represented this and that relationship. Some product types are tuples and classes. So for example, they're called product types because all the possible values are a product of all the possible values of the things that they contain. So if we have a tuple of a Boolean and a Boolean, we know that a Boolean has two possible choices. So 2 Booleans is 2 times 2 is 4 possible values. We also have sum types, which are what we're going to be focusing on today. Sum types represent a this or that relationship. The simplest form of a sum type is a Boolean. So if you have a Boolean, it can either be true or false. Each one of those are 1. And it's called a sum type because all possible values are a sum of all the possible values of the thing that they contain. So 1 plus 1 is 2 possible values. So that's great, but kind of going back to the original problem that we were talking about, what happens when we want to bundle together like different options or different things in the same category, but each one is kind of a little bit different? Maybe they have different properties or attributes on them. One way we know is the visitor pattern. Another way is the more simple approach that we might be familiar with. What you can see here is this is just using TypeScript. We have a class that has different properties on it: a backend operation state, data, loading, and error. We then have a render backend operation state that takes an instance of that state, and then depending on which attribute is passed in, which one is defined, we do different things. So we just have a bunch of if-else statements. So we can have a backend operation state that has data, and if that has data, then we want to show data, etc. So that's all fine, but one issue here is that we can actually compile this and pass in invalid states. So what happens if we have operation state with data and an error, or data and a true Boolean and an error, or even worse, if we have an operation state with none of those things defined? There's no safeguarding here. We can basically pass in invalid states. So going back to our ADTs, sum types or discriminated unions are another way of kind of handling this situation. Some examples in different languages. In Scala, it's just called a sealed trait. So here we have the sealed trait backend operation state. And each of the cases are classes themselves, and they each have different properties, can take different parameters. And then we have a render backend operation state that takes an instance of that state and does some pattern matching to determine, based on the case, what to do. As you see here, we have a keyword match. A lot of these languages have some similar keyword that allows you to do the pattern matching. In Kotlin, it's just called a sealed class. So again, you have the sealed class operation state. Each class within it can take different parameters. And then we have the function, the render operation state, which takes an instance of the state and uses the when keyword to do the pattern matching based on the case. And actually in Swift, we can use enum, because in Swift, enums are discriminated unions, or they act like them. So we have the backend operation state, different cases, and then we use a switch to switch on, depending on the case, determine what we should actually do with that. In all these examples in these languages, really the main point here is that you'll notice that if you pass in a case or a state that does not exist, or you add a case and then don't handle it in your pattern matching function, you'll get compilation errors. So it gives that that kind of safety when you're writing your code, that you can't actually pass in a type that doesn't exist within this super type. So that's all great, but I don't actually use any of these languages. So I was looking for ways that I could implement something similar in a language that I do use, such as TypeScript. So this is an example using TypeScript. We use the type keyword here, and so we basically have our backend operation state. We have different interfaces defined for those different options. So we have completed, in progress, failed. When we define our interface, you'll notice here that we do actually have to have a discriminant actually defined on the interface, usually denoted with the word or the keyword kind. That's a little bit extra work that you'd have to do in TypeScript that maybe you don't have to do in the other languages. And then in our function, where we're doing the pattern matching, we're switching on the state.kind. You'll also notice here that we do have to have a default state, where in the other ones we don't have to have a default state because that's automatically handled. In TypeScript, that's not handled elegantly, so we have to have a default state. So if you pass in a state with a case that doesn't exist, or you pass in, or you define another case that's not handled in this pattern matching function, then this will help you get the compilation errors. Using that in maybe some other real-world situations, you can also implement Redux using TypeScript using the discriminated union. So this is just a classic Redux example. Your reducer is switching on an action type, and usually that action is passed into the dispatch as just a simple JavaScript object with some type defined. Doing that using ADTs in TypeScript, we have our type counter action, which is either an increment action or decrement action, which are both interfaces. We have the discriminant defined as kind, and I just also put here increment action can take another parameter such as by, how much you want to increment by, whereas decrement, for example, could be hard-coded as 1 in your reducer. So again, that just shows that you have flexibility with these different subtypes, what they can each contain. And finally, you can also use the discriminated unions when you're dealing with observables. For example, in TypeScript and Angular, you might have a function that returns an observable from the backend. And then you take that data and you subscribe to that function. And when you have that data, you do something with that data. If you have an error, you instead do something with that error. This error here is really a catastrophic error. You're not dealing with the different errors that you might get from different emissions throughout the stream. So implementing something with an ADT or discriminated union with observables. Here we have our get data ATT function, and basically when we make the call to get some kind of data, we're mapping the data to a completed instance, and then we're also catching errors and mapping that or putting that into a failed instance. And then the start with is just an RxJS operator that allows you to start any kind of observable with something specific. So I'm just starting it with an instance of in progress, so maybe I can show a loader before getting the data or the errors. And basically, what you can see at the bottom here is we're subscribing to that function, and then our render backend operation state that does the pattern matching actually becomes our subscriber that we pass into the subscribe function. So as it gets emissions, it's able to deal with each individual emission, and if it's an error is emitted, it's able to deal with that and continue on with getting other emissions and hopefully data at some point. So yeah, that's it. using ADTs and discriminated unions to kind of handle these kinds of data structuring issues.
Thanks, Nichole. Do we have questions?
Hey, Nichole, I'm curious if in doing this learning, has it affected the way you think about, coding in day-to-day stuff at all?
Yeah, I mean, I would think so. I think it was really interesting to learn about it. As I said, I'm using mostly TypeScript right now, and there are, as you probably saw in some of the examples, it takes a little bit more effort to kind of put the structure in place than maybe Scala or Kotlin or more functional languages. I know Elm also has them. So yeah, I mean, I definitely think that there are definitely some advantages to using these. I don't know if I would go out and start changing things right now, but definitely something that I would consider in the future moving forward.